For generations, the streams and rivers of Appalachia have bled orange. This is the visible scar of acid mine drainage, a toxic legacy of the region's long history with coal. When abandoned mines fill with water, a chemical reaction begins. Water-rock-air mix to create a sulfuric acid solution that poisons everything it touches. It kills fish. It destroys plant life. For years, it has been seen as one of the most stubborn environmental problems in states like Pennsylvania and West Virginia, a costly mess with no easy fix. It is a pollution that seems to offer nothing but loss. But what if that story is wrong? What if this toxic water held a secret? Scientists have made a discovery that could change everything. They have found that this same polluted water, this blight on the landscape, is carrying something incredibly valuable. Dissolved within the acidic flow are rare earth elements. These are the critical ingredients for our modern world. Suddenly, the problem of acid mine drainage looks different. It is no longer just a liability. It could be an asset, a source of wealth hidden in plain sight, flowing through the forgotten hollows of coal country. The scale of the pollution is staggering. Across the United States, more than 13,700 miles of streams are contaminated by this acidic runoff, primarily in the heart of Appalachia. Imagine that. So what are these rare earth elements, and why do they matter so much? The name is a bit misleading. They are not always that rare in the Earth's crust, but they are rarely found in concentrated deposits that are easy to mine. The group includes 17 metallic elements: neodymium, dysprosium, terbium. You may not have heard of them, but you use them every single day. They are the unsung heroes of our high-tech lives. Magnetic, luminescent, catalytic properties. Think about the smartphone in your pocket. It is full of rare earths. They help make the screen vibrant, the speakers powerful, the motor vibrate. The same is true for your laptop, your flat-screen television, and your headphones. The transition to a green economy depends heavily on these materials. The powerful, lightweight magnets in electric vehicle motors and wind turbines are made with rare earths like neodymium. Without a steady supply of these elements, building the infrastructure for a cleaner future becomes much more difficult and expensive. The discovery that acid mine drainage contains rare earth elements is a game changer. Here is how it works. Rainwater seeps into old mines. Groundwater seeps into old mines. They react with exposed sulfide minerals like pyrite, exposed in coal seams, and surrounding rock. The reaction produces sulfuric acid. The acid dissolves other minerals and leaches metals. The water becomes a chemical soup, carrying dissolved elements downstream. For a long time, we focused on harmful elements. Iron, aluminum that stained the rivers. But the acid is not selective. It also liberates valuable rare earth elements, locked away in the rock. The acidic water does the hard work of crushing and processing ore. Scientists at West Virginia University proved this. The National Energy Technology Laboratory helped confirm it. Their research found concentrations in some streams comparable to commercial ore deposits. The resource could be economically viable. This is not isolated northern Appalachia. Map view. Hundreds of abandoned mines releasing between 500 metric tons and 3,400 metric tons per year. A steady, predictable flow of raw material. The most exciting part of this discovery, not just that the rare earths are there, it is that they might be much easier to get out. Traditional mining is a brute force endeavor. You have to dig up solid rock, haul it, crush it into a fine powder, and then use harsh chemicals or high heat to separate the metals. Each step is expensive and generates its own waste. It is a bit like trying to get a teaspoon of sugar out of a giant, solid block of concrete by smashing it with a hammer. Extracting metals from acid mine drainage could be fundamentally different. The acid has already done the first, and often hardest, step of the process. It has liberated the metals from the rock and put them into a dissolved or aqueous form. In this state, the rare earth elements are free-floating ions in the water. This means you do not have to dig, blast, or crush anything. The feedstock is a liquid, which can be pumped and processed much more easily than solid ore. The challenge shifts from rock mechanics to water chemistry. The potential financial numbers are catching people's attention. from state governments to federal agencies. The idea of turning a multi-billion-dollar environmental liability into a multi-billion-dollar asset is a powerful motivator. This is moving beyond the laboratory and into the real world. Pilot projects are already underway, backed by public funding and private investment, to test whether this process can work at a commercial scale. These projects are the crucial next step in proving the technology and understanding the real-world economics. In Pennsylvania, the state budget has allocated $1.9 million for a project led by Concurrent Technologies Corp. DARS, CTC, have already built a pilot facility capable of processing 10,000 gallons of acid mine drainage per day, paving the way for larger operations. While the promise is great, the path forward is filled with challenges and risks that must be managed carefully. This is not a silver bullet. Acid mine drainage is a complex and variable resource. The chemical makeup of the water can differ dramatically from one mine to another, and even change with the seasons. The presence of impurities can complicate the extraction process, making it harder and more expensive to produce a pure final product. The chemicals used to extract the rare earths must be handled safely, and the waste products from the extraction facility must be disposed of responsibly. Building trust with these communities is essential, but for the sake of Appalachia and the nation, it is a path worth exploring.